Hello again everyone, I'm back with another Spline train video. Some people were asking how to make junctions with the Spline package I was using, so I played around and found a pretty easy way to set it up. What I have right now is a train moving along a single closed spline path, with the train's speed controlled by forward and backward forces. This is the result of 3 previous videos I made on this topic, so check those out if you want to get to this point. By the end of this video, the train will change spline paths based on a switch applied to junctions that the train will collide with, where any track transfer would happen. I'd like to mention before I get into it that I'm often available on my Discord server, so if you have any questions or just want to hang out and be a part of the community, come check it out. I'm also going to put the source code for this project onto GitHub since a few people were asking for that. And lastly, a friend and I just released our first game on Steam. It's a small but unforgiving precision platformer where you try to escape the ruin. If that's your kind of game, I'd love for you to check it out, and if you're so inclined, I'd also like to hear your feedback on it. The links for all of these are in the description. Okay, now to the junction. To start, the first thing you need to do is split the track into new paths. This is fortunately very easy with the Unity Spline package. What you need to do is select the game object with the spline container, click the Spline Editor tool button in the scene, then click the Draw Spline tool button. With that active, click on the knot you want to branch from and start building your track from there. I found that it works more smoothly if you overlap the first section of the line with the line you're branching from. This makes it so it's not noticeable when the train is physically switching rails, otherwise the train would noticeably jerk. Once you have that, if you look in the spline component in the inspector, you'll see a new spline in the list with all the relevant knots in it. The knots that are part of both splines are linked knots, so those knots will exist in more than one spline array, even if they're numbered differently in each spline. Next, we need to make the junction that the train will collide with. To start, I'm going to make a script called Junction. In there, we need a reference to the spline container which holds the whole rail system. On top of that, we also want a list of possible tracks the train can branch onto from the current junction, and a current rail variable to tell which track to take when the junction is hit. For the list, I chose to hold integers which represent the indices of all possible branches from the junction. Then the current rail variable will be set to the index of the track you want in the rails list, which returns an index to the list of splines in the spline container to give you the track that you are switching to. This is a bit confusing and would be difficult to maintain when the track grows into many spline tracks, but it works for now, and I decided solutions for this would be out of scope of this video. To implement the logic for the junction, I need to know when a train cart hits the junction, which I can do with the onTriggerEnter event. I'm using trigger instead of collision since we don't want the junction to act as a wall, just something to pass by and trigger the track switch. Inside the function, we need a reference to the cart passing through the trigger, which we can get by using the getComponent method on the collider passing through. If that collider is indeed a rail cart, we need to tell it to switch to the proper track, which we will do in the railcart script itself, then expose that function to be accessed by the junction. So in the railcart script, I'll add a hitJunction public function, pass in the spline it needs to switch to, and change the current spline to the new spline. Back in the junction, we can then call this newly made function and pass in the rail variable, with the index being the value in the rail list indexed by the current rail variable. I know this is probably confusing, I definitely confused myself implementing this, but I'll show you what's going on in the inspector once things are set up. Just trust me on this for now. Next thing is to spin up a basic model for the junction. The look doesn't really matter to me right now, but the position of the collider does. Make sure to remove any colliders if you use built-in objects to create this. Then add a box collider to the top level of the object. Make sure isTriggered is toggled on. This is also where we'll add our junction script. Once that's on there, I'll add it to where the first track split happens. In the inspector, first thing is to add the object that has the spline container to the rail reference. We then need to add an index for each track this junction can split to. To find this out, go to the object with the spline container and click the Spline Edit tool in the scene. From here, you can expand the splines in the editor, then click on knots in the scene to see which splines they are a part of. For example, if I click on this knot, knots 2 and 0 are respectively highlighted for spline 0 and 1 in the inspector. This is a pretty simple example since I'm only working with 2 splines overall. So back in the junction, I want 2 items in the rail list, one for each of the splines. Since I'm working with splines 0 and 1, those are the numbers I add into the list, as those numbers represent the index of the splines in the spline container. The current rail variable will then need to be set to the index of the rails list that you want the junction to be pointing to. This is the variable we'd want to be able to change on the fly in-game to change the route of the train. Therefore, I'm also going to add a slider to the UI, so I can easily change this while I'm playing. I made the slider snap to whole numbers, and the range is from 0 to 1, since we just have the 2 splines here. Something other than sliders would need to be used if there were multiple splines that weren't sequential, but this works for now. I'll do a quick test to see if the train changes from the default spline 0 to spline 1 when it passes through the junction. Looks like it's working. However, we run into the problem of switching back to spline 0 when looping around, so another junction is needed for this. And since this is converging a track instead of diverging, this needs to always be set to spline 0. This, however, introduces a bit of a problem when we decide we want to change directions of the train and go backwards. These junctions are directional, and if you decide to back up while halfway through the junction, it will break since you're switching from spline 0 to 1, but not the other way around if you reverse the train, which is not really desirable. The easiest way to get around this would be to have 2 junctions at each fork, with the last one you hit, in the direction the train is going, dictating the track that needs to be switched to. So I'll add a new junction to each of the forks and color them so I can keep track of which junctions I'm changing. With that, it looks like we have a fairly functional track switching system. The system used for choosing splines from the junction could be improved by abstracting the spline indices to be more clearly identified, but this is at least working. I'll leave the optimizations for you to figure out for now. Let me know in the comments what you think, and thanks for stopping by. I'll see you next time.